Hello everyone, thank you for signing in and watching my live stream. I'm Mr. Matt and this is Dr. Tot. Would you like a cookie, Dr. Tot? Yes. Welcome to Algebra 2. This week we're going to talk about graphing quadratics, quadratic equations. And first off, I want to apologize. I wasn't able to stream on Monday or Tuesday. I'll be putting out a recording. I'll go live, but not at the regularly scheduled time. But I'll put out a recording, another live session for stream 2. Hopefully before Friday, so that we can get back on track for finishing up graphing quadratics in stream 3 on Friday at our regularly assigned time. So I appreciate your understanding. We had some internet connection problems, so wasn't able to get online those days. But today we're going to talk about graphing quadratics, and we're going to talk about that. We're going to talk about graphing quadratics in the context of 3 different forms that quadratics can be presented in. They can either be presented in the standard form, ax squared plus bx plus c is equal to 0. They could be presented in the vertex form, which is y is equal to a times the quantity x minus h quantity squared plus k. Or they could be presented in the intercept form, which is y is equal to a times the quantity x minus p times the quantity x minus q. So we're going to look at all 3 of those circumstances and what they mean and how the different forms give you hints at different characteristics of the equation and the overall graph, which will allow you to surmise certain characteristics or certain conclusions about the graph that will make sketching it a little bit easier. So let me go ahead and share my screen with you. Just a reminder, these are live sessions, so there is a little bit of a delay with the iPad, but we're going to go ahead and I'll keep track of that in the broadcasting screen. If there's any questions at any point, just let me know. You can drop them in the live chat feed, or you can put them in the comments below and I'll get back to you. So the overarching theme here is that, oh, and my iPad, I do apologize. Give me 1 second. I'm so sorry. It's not responding as it should be. So let me just reset it here. Hopefully that fixes it. My apologies. Just give me 1 second. Okay, very good. So the overarching theme here, good, it's responding. I'm sorry about that. It was a little bit of a hiccup there. So overarching theme, the approach to graphing quadratics depends on the form of the equation that you're given. There are 3 forms of quadratic equations that we're going to talk about at least. We have the standard form, the vertex form, and the intercept form. Now the standard form is y is equal to ax squared plus bx plus c. Notice that a is the coefficient that is next to the x squared variable. B is considered the coefficient next to just the x variable, that's x to the first power. And c is the constant value that has no variable attached to it. I make those delineations because they don't have to give it to you in this order. The x squared value doesn't always have to come first. You might have to rearrange them so that they're in order of the degree of their exponent. The x squared has an exponent of 2, the x has an implicit exponent of 1, and the c value has an implicit exponent of 0. X to the 0 power, anything to the 0 power is 1, c times 1 is c. So technically we would consider c as having a 0 power exponent. variable to a 0 power exponent, even though it doesn't have a variable technically. But it should be in that order, at least when we're assigning the values of a, b, and c. Now, there's an equation, or there's an expression rather, that we can use to understand the axis of symmetry. Quadratic equations are parabolas, meaning that they have that characteristic U shape. So to graph them, we're really interested in the axis of symmetry, which is the vertical line where the vertex of the parabola occurs. And there's a convenient expression, negative b over 2a, to find the x-coordinate of the vertex, or in other words, the axis of symmetry around which the parabola is symmetric. So you could fold one side over based on this line, this vertical line, and they would overlap exactly. Then we can plug in values that are to the left and to the right of the vertex to plot out points that you can ultimately connect together into a graph of the overall equation. So that's our kind of overall solution pathway. That's our approach, that if we're given a quadratic equation in standard form, we can surmise the axis of symmetry using negative b over 2a. That gives us the x-coordinate of the vertex. We can always plug that x-coordinate into the equation and solve for the y-coordinate if we really needed to. But you also know the vertical line around which the U shape is symmetric. So you can test values. You make a little t-chart and test values to the left or to the right of that axis of symmetry in order to connect the values, the dots together and sketch out an overall graph. I do want to make a point here. Last week we touched on completing the square, and we're going to have a lot more work with completing the square. But there was an expression that's related to completing the square that's very close to the expression for calculating the axis of symmetry, and I don't want you to get them confused. So I want to make it known to you clearly. So for completing the square, we were using the expression b over 2 quantity squared. But notice the difference between graphing the expression that we use to solve for the axis of symmetry and graphing a standard form quadratic. That is negative b over 2a. So they're two separate expressions, but they're very, very similar to each other, and they're very easy to get mixed up. So I just wanted to clearly put those out there, that here we're going to be using this guy, negative b over 2a. So I'm going to give you 3 minutes, and I'd like you to look at question number 1. I want you to first use the expression negative b over 2a in order to solve for the x-coordinate of the vertex, and then you can test values to the left and to the right. So I'll give you 3 minutes, and then we'll go through the solution and look at some other examples. I'll keep track of the time in red here and update it per minute. Okay, so looking at this equation, we have y is equal to 2x squared plus 4x plus 2. So a here is equal to positive 2, b is equal to positive 4, and c is equal to positive 2. So if we were to substitute those values for a and b into the expression negative b quantity divided by 2a to find the coordinates of the x-coordinate of the vertex or the equation for the axis of symmetry, then we would have negative 4 divided by 2 times 2. So negative 4 over 4 is going to be negative 1. So we have x is equal to negative 1 is the axis of symmetry. So I'm going to kind of sketch in a dashed line. So I know that this U-shaped graph, and I know it's a U-shaped graph because it's a quadratic. This U-shaped graph is going to be symmetric around this equation, around this line, x is equal to negative 1. So now I'm going to just test a few different points. I'm going to write out a chart, and I'm going to go a little bit to the left of negative 1, so I'm going to go negative 3. I'm going to include negative 1, and then I'm going to go a little bit to the right of negative 1, so I'm going to go to positive 1. So if I test this equation for what the value of f of negative 3 is, I'm going to just substitute in negative 3 every time that I see an x, and then solve. Actually, let me get some more space here. So negative 3 squared is 9, so I'm going to have 2 times 9 plus 4 times negative 3 is a negative 12 plus 2. So 2 times 9 is going to be 18. So I'm going to have 18 minus 12 plus 2. Negative 12 plus 2 is going to be a negative 10. 18 minus 10 is 8. So when x is equal to negative 3, y is equal to 8. If I test the value of negative 1, I'm going to get 2 times negative 1 squared plus 4 times negative 1 plus 2. Negative 1 squared is positive 1, so I'm going to get 2 times positive 1. Negative 1 times 4 is negative 4, so that's going to turn into minus 4 plus 2. 2 times 1 is 2, so I'm going to get 2 minus 4 plus 2. 2 plus 2 is positive 4. Positive 4 minus 4 is 0. So at negative 1, y is equal to 0. And then finally, if I test positive 1, I'm going to get 2 times positive 1 squared plus 4 times positive 1 plus 2. 1 squared is just 1. 2 times 1 is just 2. 4 times 1 is just 4. So I'm going to get 2 plus 4 plus 2. That's going to be 8. So I'm going to just count by 2's here on the y-axis. So when x is equal to negative 3, y is equal to 8. And I'm counting by 1's on the x-axis, just to be clear. When x is negative 1, y is 0. And when x is positive 1, x is positive 8. So now I have these 3 points, including the vertex, so I can kind of just sketch in this U shape, which I know this quadratic is because it is a quadratic. By the nature of it being a quadratic, I know that it's a U-shaped graph. If you have any questions, then please let me know. Otherwise, let's take a look at the second problem. We have y is equal to 3x squared minus 12x plus 2. So I'm going to give you 4 minutes. Please graph this equation, and then we'll go over the solution. Okay, so I started to solve. So a is equal to 3 here, b is equal to negative 12, c is equal to positive 2. Substituting a is equal to 3 and b is equal to negative 12 into the expression negative b over 2a will give us negative times negative 12, or negative 1 times negative 12 over 2 times 3. A negative times a negative is a positive, so that's going to give us 12 over 6, which is 2. So that tells us that the axis of symmetry occurs at x is equal to positive 2, or in other words, the x-coordinate of the vertex of the parabola is positive 2. So I put in a little dashed line at x is equal to positive 2, and now I'm going a little bit to the left of positive 2 and a little bit to the right of positive 2 and including positive 2 in my table. So I'm going to evaluate the points, excuse me, 0, x is equal to 0, x is equal to 2, and x is equal to 4. If I plug in 0 for x, then I get positive 2. If I plug in 2 for x, then I get negative 8. And if I plug in positive 4 for x, then I was just finishing this. Would give me 48 minus 48 plus 2, leaving me with just a positive 2. So I'm going to count on my y-axis by 2's, so I can fit all of this in here. And then count on my x-axis by 1's. So at x is equal to 0, y is equal to positive 2, so that's this point right here. At x is equal to 2, y is equal to negative 8, so that's this point right here. And when x is equal to 4, y is equal to positive 2. So now I have enough information to plot out a sketch. So it would look something like this. Now let me know if you have any questions. Otherwise, let's take a look at question number 3, which is asking you to sketch the graph of y is equal to 2x squared plus 16x minus 4. So I'll give you 4 minutes. After 1 minute, I'll start to solve just to save some time. And then we'll move on to the next form of the quadratic equation we can see. So 4 minutes. Okay, so this one, in this problem, a is equal to 2, b is equal to 16, and c is equal to negative 4. So substituting into the expression negative b over 2a, we get negative 16 divided by 2 times 2, which is going to be negative 16 divided by 4, which is negative 4. So at x is equal to negative 4, we have the axis of symmetry. So I'm going to test values, one value to the left, one value including negative 4, and one value to the right of negative 4. So I chose negative 5, negative 4, and negative 3. So when we evaluate the function or the equation at x is equal to negative 5, then we get 2 times negative 5 quantity squared plus 16 times negative 5 minus 4. And so negative 5 squared is going to be positive 25. 16 times negative 5 is a negative 80. And we have that negative 4 carrying on, so we're going to end up with 50 minus 80 minus 4. So 50 minus 80 is going to be a negative 30. Negative 30 minus 4 is going to be a negative 34. Substituting in negative 4 for x, we're going to get 2 times negative 4 squared plus 16 times negative 4 minus 4. So negative 4 squared is positive 16. Positive 16 times negative 4 is going to be a negative 64. So we get 2 times 16 minus 64 minus 4. 2 times 16 is 32, so that turns into 32 minus 64 minus 4. 32 minus 64 is negative 32. Negative 32 minus 4 is negative 36. Now I'd suspect that this next value of f of negative 3 is going to be negative 34 because we're equal distance from the axis of symmetry from x is equal to 4. So I would suspect it to be the same value because the parabolas are symmetrical as the output when x is equal to negative 5. But let's just go ahead and check here. So we're going to get 2 times negative 3 quantity squared plus 16 times negative 3 minus 4. So negative 3 squared is 9, so we're going to have 2 times 9 plus 3 times 16 times negative 3 is going to be a negative 48, and then we have that minus 4 carrying on. 2 times 9 is 18, so this is going to be 18 minus 48 minus 4. So 18 minus 48 is going to give us a negative 30. Negative 30 minus 4 is indeed negative 34. So this one's a little bit hard to graph on this particular graph, but let me just count by tens on my y-axis. And I'm going to count by ones on my x-axis. So at negative 5, we're at negative 34. So that's going to be about here. And let me do a different color. At negative 4, we're about negative 36. And at negative 3, we're at negative 34. So it doesn't have to be exact, but something like this. And we really need some extra points here to see how this actually increases to the left and to the right, because we're so close to the axis of symmetry. But just for a sketch, this is absolutely fine. So if you have any questions, then please let me know. And we'll probably just have time to get into one example of the next form, but that's okay. We'll pick back up in session 2. So the next form that we're going to look at is the vertex form of quadratic equations. So Our process or our pathway to solve when we're presented with the vertex form is that we can use the equation, we can examine the equation and determine directly what the actual coordinates of the vertex are. Therefore, just like when we knew the axis of symmetry, now we have a definite point that is the vertex, and so we can just test values to the left or to the right, to the left and to the right of that vertex, and then sketch out a graph. So the vertex form, we use the coordinates of the vertex, which is negative h comma k, to establish the center of the parabola. Then plug in values to the left and right of the vertex to plot out points that you can ultimately connect together into a graph of the equation. Now, what's tricky is that this value in the vertex form has a negative sign attached to it. The h value, you have to remember, is opposite common sense. Because in the actual formula, it has a negative. Notice that the k value doesn't have a negative attached through addition. So there's no implicit operation in the formula that is switching the signs of any of these inputs for k. But for h, the sign does get flipped. So that means that the h value, or the horizontal shift value, or in other words, the x coordinate of the vertex, is opposite common sense. That means that if it looks like it's negative 2, left of the 0, 2, then it's actually positive 2. It's right of the 0, 2. The k value goes with common sense because it's attached with addition. So if the k value is positive 3, that means it's up 3 from the origin 0, 0. If the k value is minus 5, it goes with common sense. It goes with common sense. I'm sorry. And so that would be minus 5 or down 5 from the origin. If the h value was negative 3, that doesn't mean left 3. It's opposite common sense. So that would actually mean right 3 from the origin, an x coordinate of positive 3. If it was x plus 2, you might think it's to the right 2, but remember it's opposite common sense, so the x coordinate is actually negative 2. So let's look at this value. I'm going to give you, this equation, y is equal to 2 times the quantity x minus 2 quantity squared plus 1. I'm going to give you 4 minutes. I'd like you to graph or sketch a graph of that equation in vertex form, and then we'll go through the solution. This will bring us up to the end of class today, but we'll pick back up in session 2 with some other examples of the vertex form as well as the intercept form. So 4 minutes, and then we'll go through a solution. Okay, so I just wanted to make my camera a little smaller there. So if we plotted out points, first of all, well, if we recognize from the equation that the h value of -2 is opposite common sense, so that actually means an x-coordinate of the vertex of +2. The k value is with common sense, that's +1. So the vertex of this parabola is 2, 1. That allows me to establish, 1, the vertex, and then also notice that the vertex occurs on the axis of symmetry. So I drew in a dashed line to represent the axis of symmetry there. And then I'm just going to test 2 points, one to the left and the other to the right of the vertex. So I picked easy to work with numbers, 0 and then 4. They're equal distance from 2. So evaluating 2 for x, I get +9. Evaluating 0 for x, of finding the value f of 0, I get +9. Evaluating +2, or finding f of +2, that gives me +1. And f of +4 gives me +9. So I can plot out those points. On the y-axis, I'm counting by 2's. On the x-axis, I'm counting by 1's. So at 0, I'm at 9. That would be about here. At 2, I'm at 1. So actually I need to correct that original dot because I changed my scale. So at 2, I'm at 1. It's about right here. And at 4, I'm at 9. So then I can connect my dots together and sketch an overall plot like this. If you have any questions on anything that we've done today, please don't hesitate to either drop them in the live chat feed, or if you're watching this recording, to drop them in the comment section below. I hope that this was helpful. And if you do find them helpful, these videos helpful, I would welcome you to subscribe and like the channel. I thank you guys very much for your attention and for watching the stream. I will put up a recording for stream number 2, like I said before, and then we'll be back on track for stream 3 on Friday. I hope you all have a wonderful night, and if there are no questions, then Dr. Tot, do you want to say goodbye to everybody? Come on, you gotta say goodbye. Can you say bye? Can you say bye? Come on, say bye. Can you say bye? He's like, kind of struggling here, huh? You gotta say bye. Oh, good boy. Very good. Say bye. All right, thank you guys very much for signing in. Have a wonderful night, and I'll talk to you all on Friday.